everybody. Ernest T. Bass here, and this is the Pythagorean Theorem, and this deals with right triangles, you guys. Only right triangles. So, right triangle right here. And on a right triangle, you have two legs that give me the right angle, and then the third piece is called the hypotenuse. I'm sure you've heard of that before, but there's two legs in the hypotenuse. And the right triangle goes like this. Pythagorean Theorem goes like this. Each leg squared added together equals the hypotenuse squared. This always works and only works on right triangles. Okay, so you'll see some lengths and they'll say, is it a right triangle? And you just got to take the smaller two sides and square them and see if it equals the third guy squared. The hypotenuse is always the biggest side. So find the missing length. Okay, so here we have a right triangle. I'm just going to go ahead and plug in my triangles. A squared plus b squared equals the hypotenuse squared. So in this case, 3 squared plus 4 squared equals x squared. Okay, so 3 squared is 9, 4 squared is 16. You have to add those together to get 25. And then can you think of a number that you square it gives you 25? Okay, it equals 5. It's the square root of 25. Okay, all right, nice and easy, right? Okay, this one here. Okay, same thing. 12 squared plus x squared equals 15 squared. I think I wrote x squared plus 12 squared equals 15 squared, but that's okay. Okay, 12 squared is 144. 15 squared is 225. I'm going to go ahead and subtract the 144 from both sides, and I get 81 over there. So when I square root 81, that's a nice perfect square. That gets me 9. Okay, so the answer is 9. Okay, here you're not going to get a nice whole number. We're going to get a simplified radical answer. Remember that from last two sections in section 8.4. We just did those in section 8.4 part 1 and part 2. All right, so 10 squared plus y squared equals 20 squared. 10 squared is 100. 20 squared is 400. You're going to subtract 100 from both sides and get 300. Then I'm going to square root 300, okay? And then remember how we did this? We break it down. 300 is 30 times 10. And then 30 breaks down to 6 times 5, and then 10 breaks down to 2 times 5. All right, now I don't think I circled these, but I should have circled the prime numbers, the 5, the 2, and the 5, but this 6 breaks down a little bit more to 2 times 3. So there's the prime factorization, 2, 3, 5, 2, and 5. Okay, so I'm going to put that all inside that radical, and I'm going to put them in order. Okay, 2 2's, a 3, and 2 5's. Okay, now remember, we need 2 on the inside that brings 1 out. So 2 2's brings 1 2 out. So I shaded them black here, so brought out this 1 2 right there. Okay, and then 2 5's on the inside is going to bring 1 5 out. Notice I shaded those 5's black. And I'm left with that leftover 3 right there, so the answer is going to be 10 root 3 on this one. Okay, one more in terms of x, you guys. Okay, can you see which one the hypotenuse is? It's opposite that right angle. There's the right angle, so go straight across. That's the hypotenuse. This one's the one that equals itself, you know. So this side squared plus this side squared equals this side squared. Okay, does that make sense? All right, x plus 1 squared, it means x plus 1 times x plus 1. And then we're going to FOIL that x plus 1 times x plus 1 out. So first times first is x squared. Outer times outer is 1x, and then inner times inner is 1x, and finally last times last. All right, going to combine like terms. All right, 1x plus 1x gets me 2x. Notice they both have an x squared on both sides of the equal sign, so if I subtract off x squared, they cancel each other out. Now I'm going to subtract 1 from both sides and get 48. Divide by 2, and I get 24. Okay, you're going to see some, they'll just give you lengths, A, B, and C, and they'll tell you to find the length of the third side if it's a right triangle. And then you just do A squared plus B squared equals C squared. You guys will do fine, okay? It's a nice, easy lesson.